what does a cloud engineer actually do every single day? Now, if you're trying to become a cloud engineer in 2026, I just want to ask you a very, very simple question. What does a cloud engineer actually do every day? And be honest, because a lot of people say they want a cloud job, but when you ask them, what does a job actually involve? The answer is very vague. They can't really tell you. They say things like working with AWS, deploying stuff, managing cloud infrastructure, doing DevOps, using Terraform. And yes, technically some of that stuff is true, but it's still very vague. And being vague is really dangerous because if you don't know what the actual job looks like, you don't know what the skills you need to build and get hired. You won't know what projects you need to build. You don't know what to put on your CV. You don't even know how to prepare for interviews. And you don't know whether you're actually becoming job ready or you're just collecting more random cloud knowledge and information. So in this video, I want to explain what a cloud engineer actually does every single day. I've been there myself. I've gone through the ranks. I've built my own cloud AI consulting companies. I've got a software company. So yeah, I feel like I'm pretty well qualified to tell this, right? I've got the biggest AI and cloud engineering channel on YouTube, no doubt #1. So this isn't going to be a day in the life TikTok version that you see where someone makes a coffee, pretends to work, open Slack. This is the real version, the actual work, because cloud engineering is not memorizing services. It's not about collecting certifications. It's not clicking around the AWS console forever. Cloud engineering is about keeping systems running secure, scalable, reliable, automated, and cost effective. A lot of buzzwords, I know, but that's the job. And we're going to break down everything right now. Once you understand it, everything else that you start to do and learn will make a lot more sense. So what's the real job? The simplest way to understand what cloud engineering is: a business has software, and that software needs to run somewhere. It needs servers, it needs storage, it needs networking, it needs databases, it needs security, monitoring, backups, cost control, access controls, and all of that needs someone to design, build, manage, automate, secure, and troubleshoot. That's the cloud engineer. You're not hired because a company loves AWS. You are hired because the company has systems that need to work. Customers need to access the applications, developers need somewhere to deploy, security teams need to know that data is protected, managers need a system to be reliable, finance doesn't want AWS bills to get out of control, and when something breaks, someone needs to figure out what on earth happened. And that's where you come in, my friend. So the job isn't, I know EC2. The job is, can I use compute? Can I use networking, storage, identity, monitoring, and automation to support a real business system? And that's the difference, because beginners, they learn services, but real engineers, they operate systems. And here is the mindset shift that I want you to understand very early. A cloud engineer does not exist to play around with technology. A cloud engineer exists to solve business problems using technology. Technology is just the tools in your toolbox. You are here to solve problems, and that's why the role matters a lot. So if a company's website goes down, that's not just a technical issue, right? That's lost revenue. It's lost trust. It's angry customers. It's more support tickets. It's pressure from leadership. If a database is exposed publicly, that's not just a misconfiguration. It's risk. It's compliance issues. It's potential breaches. Could also equate to fines. If deployments take 2 weeks, that's not just annoying developers, right? That slows down the entire business. If cloud costs double and nobody knows why, that's not just an AWS billing problem, that's money being wasted every single month. So when you're learning cloud, don't just ask, what does this service do? Ask, what business problem does this help to solve? And that's how you start thinking like a real cloud engineer. A lot of programs and content and tutorials, they just tell you, do this, click this button, write this, all this kind of stuff. And the reason why I'm able to operate at this level is because I think about the business and then I use the tools that I have access to solve their problems. So you have to change the way you think about the role. With that in mind, what does a cloud engineer actually do every single day? And it usually comes down to 7 types of work. First one is understanding requirements. Number 2, designing cloud infrastructure. Number 3, building and deploying systems. Number 4, securing access and data. Number 5, monitoring reliability and cost. Number 6, troubleshooting when things break. Number 7, automating the repetitive work. So let's go through each one individually. The first thing that cloud engineers need to understand is what actually needs to be built or fixed. And this is where a lot of beginners go wrong. They think that the job starts with AWS. It doesn't. right? The job starts with the problem. A developer might say to you that we need to deploy this application. A product manager says we're launching a new feature next month. A security team might say to you, this system needs to meet compliance requirements. A manager might say, we need this to be more reliable. A finance team might say, our AWS bill is getting out of control. And what this means is that your job is to translate that into infrastructure decisions. So you're asking questions like, what is the application? How many users will it have? Does it need to be highly available? What data does it store? Who needs access? What happens if it goes down? What's the budget? How fast do we need to ship? Who is going to maintain it? That's cloud engineering, my friend. It's not just touching AWS services, it's understanding the problem well enough to choose the right solution. And this is why communication matters a lot. If you can only speak in the technical jargon and the buzzwords, you will struggle because engineers might care about VPCs, IAM, and Terraform, but managers, they care about speed, cost, risk, uptime, and business impact. So you need to be able to speak in different ways depending on who you're speaking to. Does that make sense? That's how you become valuable. Now, this happens inside of my academy. We've got these great technical people that are coming through the program and they start giving the buzzwords. They say like VPC and EC2, and they give all the buzzwords, right? Highly available, scalable. And I'm just like, what did you just say, right? I'm very like direct in the feedback that I give some of our students because someone needs to give them the right structure, the right mindset, right? They can't just be saying buzzword after buzzword after buzzword. No one really cares about the buzzwords. They care about how are you solving their problem. So you need to be able to switch between the different ways that you speak depending on the audience that you're speaking to. So the second thing that cloud engineers do is they design infrastructure. And this way decide what the cloud environment is actually going to look like. For example, if a company needs to host a web application, you might think about, should I run this on EC2, ECS, Lambda, or something else? Where does the database live? Should the database be public or private? How does traffic reach the application? Do we need a load balancer? Do we need auto-scaling? How do we handle DNS? How do we secure access? How do we monitor it? How do we back it up? How do we reduce costs? And do you notice the questions here? They are not just what services do I use? They are why this service? Why this design? What are the trade-offs? Because that's actually the real skill set. A junior person or a junior engineer will look for the right answer. A strong engineer, an experienced engineer, looks for the best trade-off given the constraints that we're working with. Because there's rarely one perfect architecture. There is only the architecture that makes the most sense for the business right now. I always say this to our students inside of my academy. I say, there is no right or wrong answer. There is no perfect solution. It's all about trade-offs. And what are the trade-offs? Budget, team size, timeline, security requirements, traffic, risk, maintenance, right? Expertise. All of that matters. So if you're learning cloud, don't be memorizing the architecture diagrams. Learn to explain why the architecture exists. The third thing that cloud engineers do is they build and deploy systems. And this is the hands-on part, creating infrastructure, setting up networking, creating IAM roles, deploying compute, configuring databases, setting up storage, connecting services, writing Terraform, building pipelines, deploying apps. And this is where people really need to understand something very, very important. In production environments, nobody wants you clicking around the console forever. Clicking is completely fine, or ClickOps as I like to call it. It's fine when you are learning. Everyone starts there because you need to see how things work. But at work, in real engineering environments, infrastructure needs to be repeatable. It needs to be reviewed. It needs to be version controlled. It needs to be documented. It needs to be shared. It needs to be recreated. That's why infrastructure code matters a lot. Terraform, CloudFormation, CDK, whatever tool technology that you're using, the idea is still the same. You define infrastructure in code so the environment can be recreated consistently. Because if one person clicks through the AWS console and builds everything manually, now the knowledge will only exist in their head and they leave and nobody knows how it works. Say something breaks, the company will be in big trouble, and that's a real problem. By the way, I've come into startups and they've built their whole infrastructure on AWS using the console. And they've been running it for 3 to 4, 5 years. But now they're like, shit, like things are getting out of control. We need this all repeatable, all written in code. And they hire me to basically go and do that migration for them. It's not fun, but it pays incredibly well. So cloud engineers are not just building infrastructure. They are building infrastructure in a way that other people can understand, they can repeat, and they can maintain. The fourth thing cloud engineers do every single day is security. And I don't mean cloud security as a separate specialist role. I mean, security is actually part of cloud engineering from day zero. Who has access? What can they access? What should be private? What should be public? Are secrets protected? Is a database exposed? Are logs enabled? Are S3 buckets locked down? Are IAM permissions too broad? Are security groups configured properly? This stuff is not optional, guys. A massive part of cloud work is making sure that the environment doesn't become a security nightmare. And most cloud security problems are not dramatic movie style hacks, right? They're not like you got some random hacker in a random country coding away and trying to break into systems. They're actually boring misconfigurations. Someone opened a port that they shouldn't have. Someone gave admin access when they didn't need to. Someone made an S3 bucket public. Someone hard-coded credentials. Someone forgot to do the login. Someone left old access keys active. This is why IAM and networking matters so much, because IAM, identity and access management, it controls trust. Networking controls traffic. And if you get those wrong, the whole environment becomes very risky. So if you're trying to become a cloud engineer and you skip IAM, VPC, security groups, logging, least privilege, you're skipping a huge part of the actual job. The fifth thing that cloud engineers do is that they monitor systems, because deploying something is not the end. That's actually where the real work starts. Is the application healthy? Are users getting errors? Is latency increasing? Are servers overloaded? Are logs showing failure? Did a deployment break something? Did the AWS bill spike? Is storage growing too quickly? Are backups running? Are alerts firing, right? This is why tools like CloudWatch, CloudTrail, dashboards, alarms, logs, metrics, and monitoring systems matter a lot. A system that runs once is a lab. A system that you can monitor, secure, troubleshoot, and improve is way closer to real cloud engineering. And cost is actually a part of this too. Cloud makes it very easy for you to spend money accidentally. Wrong instance sizes, unused resources, expensive NAT gateways, over-provisioned databases, forgotten storage, right? Bad architecture. So cloud engineers also need to be very cost aware. Not because you are the finance team, but because infrastructure decisions have business consequences. A good cloud engineer is always thinking, is this reliable? Is this secure? Is this maintainable? Is this cost effective? And that's the role. The sixth thing cloud engineers do is troubleshoot. And this might be the most important part of the job, because real cloud environments are very, very messy. Things break, permissions don't work, deployments fail, the app can't connect to the database, DNS isn't resolving, the load balancer health checks are failing, the logs don't show enough data, the security group blocks traffic, Terraform states gets messy, the bill spikes, certs expire, service limits get hit, something worked yesterday, and now it doesn't. This is all real cloud engineering. Every day is different. And this is why tutorials don't really prepare people properly. In a tutorial, everything usually works if you follow along the steps. In a real job, you don't get the perfect steps. You get the symptoms. The app is down, the users can't log in, deployments failed, database is slow, the cost doubled. What you have to do now is you have to investigate. That means you're looking at logs, you're checking metric, you're reading error messages, testing assumptions, right? Changing one thing at a time, understanding the traffic flow, understanding permissions, understanding what changed. This is why troubleshooting is such a valuable skill, because it proves that you can think and not just follow instructions. So when you build projects, don't hide what broke. Document it, because the breaking and the fixing part is often where the real proof is. Even inside of my own academy in our program, when students are going through a curriculum, I've on purpose left things broken. Throughout the academy, throughout the 12 weeks of learning and the curriculum, there are parts that are literally left broken, left uncompleted on purpose. And people will message, they raise ticket, oh, I'm stuck here, I can't do this, or the tutorial doesn't give me this. And it's like, actually, I've done that for a reason. I've done that so you can go and figure out how to fix it yourself. Because in a real job, I am not going to be there to hold your hand and tell you what to do step by step. You have to go and solve it yourself, right? And then once students understand that, they really enjoy it more, right? And that's what we do different. So the seventh thing cloud engineers do is they automate. If something has to be done more than once, there's a good chance that it should be scripted, templated, or automated. So creating environments, deploying applications, running backups, checking logs, rotating credentials, scaling systems, sending alerts, updating infra. Cloud engineers are always asking, how do we make this repeatable? How do we reduce manual work? How do we make this safer? How do we make this faster? That's where scripting, Python, Bash, Terraform, CI/CD, and automation really comes into the picture. Because you do not need to be a fully fledged software engineer, but you do need to be very comfortable automating work. Because if everything that you do is manual, then you become the bottleneck. And cloud environments move way too fast for everything to depend on one person clicking buttons. So let's make this real. Imagine A company wants to launch a web application. A beginner will think, okay, I'll use EC2 and RDS. That is what I call solutionizing too early. And I see this all the time with our clients and the people that we work with and the companies that I consult for. They go and just design something and go straight for the solution. VPC, EC2, RDS, right? You get the idea. But a real cloud engineer, a real expert, someone that's been there and done it, they ask, who is using it? How much traffic do we expect? Does it need to be highly available? What data does it store? Should a database be private? How do users reach the application? How do developers deploy changes? How do we monitor it, right? How do we back it up? How do we secure the access? What happens if it goes down? What does this cost? Then they design the environment. Maybe a VPC, a public and private subnets, load balancers, app servers, databases in a private subnet, IAM roles, security groups, CloudWatch, logs, alarms, Terraform, pipelines, backups. You get the idea, hopefully. They don't just go and build. They explain it. They explain why the database is private, why the security group is only allowing specific traffic, why they chose EC2 or ECS or Lambda, why they added monitoring, what would change in production, what the trade-offs are, right? That's what the real job looks like, guys. It's not I use AWS, but it's I design a system. This is the level that you're trying to reach. And it takes time, right? But you can do it. Now, if you're watching this and thinking, okay, but I'm not going to be designing everything as a junior, that is correct. As a junior, it's very unlikely that you'll own the entire architecture by yourself on day one. Now, it is likely that you'll start with much smaller tasks, updating Terraform, fixing permissions, investigating alerts, writing documentation, helping with deployments, checking logs, creating dashboards, right? Supporting tickets, cleaning up unused resources, adding tags, helping troubleshoot networking issues, shadowing more experienced engineers. But please don't underestimate those tasks because that's how you learn. Small problems build the foundations for bigger problems. A junior fixes configs, a mid-level engineer designs systems, a senior engineer defines strategy and trade-offs. But everyone starts by learning how real environments work. So don't look down on the small tasks. Trust them, build understanding, build social capital. Then you get closer to the bigger work, right? That's how you grow. Now, the difference between a junior and senior is not just years of experience. It's actually judgment. A junior asks, what service should I use? A senior asks, what problems are we solving and what trade-offs are acceptable? A junior says, I use Lambda. A senior says, I use Lambda because the workload is event-driven, unpredictable, and doesn't need long-running compute. But if latency and execution time becomes a problem, we may need ECS or EC2. And that is the difference. It's not fancy language, it's thinking, it's context, it's constraints that we're working with, it's trade-offs. And that's why I always say on this channel, on my main channel, to customers, to people in the academy that are coming through our programs, is learning AWS is not the goal here. Becoming hireable is the actual goal. And becoming hireable means that you can think through decisions and not just name services. Now, the beauty is that you can actually start thinking like this from now, right? Whilst everyone tells you, go learn what Lambda does, what EC2 does, and all this other stuff, I'm telling you is to start thinking like a senior engineer from day zero. That's how you fast track and upskill way faster. So if we were to summarize the daily skill set of a cloud engineer, it looks like this. Cloud fundamentals, networking, Linux, IAM, compute, storage, database, monitoring, security, automation, right? You can see all the buzzwords on the screen. What you don't see is 200 AWS services. What you don't see is random Kubernetes content when you haven't even learned the basics. You don't see 5 certifications with no project. The goal is to build the skills that show up in real environments and then prove them through projects, through your CV, through your LinkedIn, through GitHub, and through interviews. Because the market can only believe what you can prove. Now, how do you know if cloud engineering is actually right for you? Ask yourself this. Do you like understanding systems? Do you like solving problems? Do you like troubleshooting? Do you like building things? Do you like figuring out why something is broken? Do you like the idea of working across infrastructure, security, automation, deployment? Do you like learning technical concepts and connecting them to real business impact? If yes, cloud can be a very, very strong fit for you. But if you're only interested because you saw a salary number on TikTok, you've got to be very, very careful because the work is not always glamorous. Sometimes it's logs, sometimes it's errors, sometimes it's networking issues, sometimes it's IAM problems, documentation, meeting, reviewing Terraform, right? Checking alerts, fixing boring problems. But boring is not bad, right? Boring is often where the real money is because companies pay you for boring problems to be solved reliably. And if you become the person who can walk into a messy infrastructure environment and say, here is what's wrong, here is what we fix first, and here is why, then you become valuable. And something else to note is that cloud engineering also opens up for you many different doors. You can go into AI and ML, data, cloud security. Also, you can go into forward deployed engineering, which is this new AI role. It doesn't restrict you like any other tech role. It opens up so many opportunities for you from that. Now, here is what I want you to do after you watch this video. Go on LinkedIn and find 5 cloud job descriptions, not one, but 5, and then look at what they actually ask for. Don't just read the title, read the responsibilities. Look for the repeated patterns. Do they mention IAM, VPC, Terraform, Linux, CloudWatch, CI/CD? Then ask yourself, can I prove that I can do any of this? Not have I watched videos on it, can I prove it? Have I built something? Have I documented something? Can I explain why I built it that way, right? Can I talk about what broke? Can I explain what I would change in production? That's how you measure progress. Not hours studied, not the amount of certification collected, not the amount of tutorials that you've watched. What problems can you solve today that you couldn't solve 30 days ago? That's the question that you have to ask yourself. So what does a cloud engineer actually do every single day? They keep systems running, they design infrastructure, they deploy applications, they secure access, they monitor reliability, they control costs, they troubleshoot problems, they automate the repetitive work, they communicate technical decisions, and they help businesses move faster, safer, and more reliably. That is the job. It's not memorizing service names. It's not chasing every new tool. It's not randomly collecting certifications. The job is solving real infrastructure problems. And if you want to become a cloud engineer, your learning has to match the job. Build the fundamentals, build real projects, document your decisions, learn to troubleshoot, learn to explain trade-offs, put your proof where the market can see it, because learning cloud is not the goal. Becoming hireable is actually the goal. And hireable means someone can look at your work and believe that this person can help us solve our cloud problems. And if you want the help building those skills, project CV, positioning, interview confidence, then join the free school community below, or just go ahead and straight away book a call with my team and see if we can help you with this. As always, I'm rooting for you. Good luck and become undeniable.